This short video will cover the tasks of adding a simple wing and a tail to this fuselage we just finished drawing. We're not going to do any blending in this stage. We'll cover that in a subsequent video because just the blends alone occupy quite a bit of effort. So we'll just do something simple here using some tools we've already built before. So let's see here. We're in the assembly level right now. I actually probably want to just right click on that part, say open part. So now we're just in the part file. We're not dealing with any interior, no internals. You turn on that plain white background. So there's just nothing inside. If we turn on hidden view, empty. No big deal. So what we'd like to do is set up first of all, a structure of locations that we can draw a wing on the aircraft and then draw a tail on the aircraft with appropriate airfoils, etc. So again, you'll only be doing half the airplane, so I actually think I want to probably roll this back. Yeah, I will. We're only going to draw half the plane, so actually instead of just rolling it back, those processes are easy enough to repeat. And I'd have to change them anyway. After I finish, I'll just delete them for the moment and go back to just half the fuselage we have for definition. The center line of the wing is going to be the center of the airplane, no big deal. So I want to then go and create another plane offset from that center line out some distance. And of course, this is where the entire design process of an aircraft comes from. Let's go out something pretty far, 24 inches. Now, if you're saying, well, isn't this exactly like the other video you made, Dr. Hayes? Yes, yeah, it is. But this time we're actually going to be doing a tail and other things and building this up for the reasons of lofting and smoothing an entire aircraft and the joints and everything between them. Okay, so we'll put that 14 inches out. That'll be a 28-inch span wing, which for the vehicle's design and competition that we're kind of basing this off of, that's entirely a reasonable size. So on the base right-hand plane, let's do a sketch. And of course, as you remember, instead of drawing an airfoil again, we'll just go to Tools, Blocks, Insert. Let's see if I still have that on the desktop from my previous video. Hey, yeah, that's good. So we're going to have a very high lift airfoil. Let's do something pretty big at first. So 14 inches, 0 degrees incidence. Oh, wow. Okay, that's way too big. Not 14 inches. 7 inches? Yeah, that'll work. Maybe for reasons of blending, we'll go 6. So that's something to keep in mind. Like if you were going to be using a large chord airfoil and you had very, very high camber, the reason I backed away from the root chord of 8 inches here is that look how much of the fuselage height that occupies. You would be able to do a blend if you had to, but that blend is now going to start creeping into very angled portions of the fuselage. You'll be getting into something, attachments at 45 degrees, etc. So could it work? Yeah, probably. Especially with airfoils as high, you really do probably end up with some root incidence. Apologies. Some positive root incidence. So there we go. Just a difference in sign conventions, because you're using an airfoil like this presumably to get very, very high lift capability. So having some root incidence at takeoff usually helps. So I'll shrink it a bit, but actually I think that root incidence looks really nice, so I'll keep it. Please don't base your actual design decisions on only what looks nice. You do need to look nice, but you also need to have some science occasionally inside of your aerospace decisions. So here we go. Let's put that in there. Call it good. That was easy. Exit the sketch, and then out here on this other plane, which we call plane 5, had some sort of dimension thing engaged. Let's do a sketch on that plane, go normal to it, do the same thing here, insert, maybe it's tools, yeah, tools, blocks, insert, we should already have that one listed. For now, we'll keep the same airfoil because I only have one block saved on the desktop. You could have any number of airfoils made. In fact, I think some of the foils have been saved in our Google Drive folder for your easy application. So instead of having a 1-inch chord, let's do something smaller, 4 inches, 0 degrees. It's interesting, it's keeping the same angle as before. That's frustrating, actually. Change it to 3, change it to 0. That's interesting. So it's referencing the previous block. Let's see if I can get around that somehow. So blocks, insert. I want to link to file, not to the other block. That's frustrating. Okay. Let me see if I can just select it again. There we go, link to file. Okay, so that reset it. That way you're not basing it on previous block settings. You're just making your all new one. So 4-inch chord, and actually let's that already gives it a decent amount of washout. And this is where you'd set dehedral, how far up and back, dehedral line sweep really, you want the wingtip to be from the root. So actually I'm going to set this up, and this is the dimension I'm going to be modifying a bunch, so that the quarter chord is unswept, which will be a little bit challenging, but for right now we'll just keep that dimension at whatever it was. Let's actually put a point on this line. Oh, no, can't do that, of course. That makes far too much sense. Cancel. Point there that is horizontal from that location using constraints. Okay, then we can dimension that. We knew the wing tip was, let's see if we can do a relation. That would be nice. Never tried this. We'll see how it works. Nope, nope. Well, surely not. That probably won't work. No. Yeah, it's just not going to work out. So 25% of 5 inches, I think, is what we set the tip at. Maybe that's wrong. I can check again by just double-clicking on that block. Going in, it's actually 4. Okay, let's see here. What's 4 divided by 4? Yeah, okay. So that's 1 inch back, 25% of the chord. We need to do the same thing here for the root airfoil. Which you could also, of course, figure this out mathematically. This root airfoil was 6 inches long. Okay, so I will, for the sake of convenience, put a dot on that chord line that is, let's get the actual path. There we go. The parallel path. 6/4 of an inch back from the front. Okay, so now we can actually get this other. Oh, that's interesting. The point reference changed. How annoying. Or did I? Nope. Yeah. Okay, that's why sometimes your relationships break. SolidWorks grabs a different point that you didn't actually want it to be referenced to. But that's all right, because all I'm going to do now is take this point, put it straight over the other point, make them vertical to one another. So that means in the right-handed plane projection, you will have 0 quarter chord sweep, which makes your aerodynamics team very happy. 1 inch leading edge of the tip higher than the root leading edge should be good to go. And this will give us a nice little bit of dehedral to go across the airplane. So at this point, you have both of the sketches you need to make a wing. Go to Surface, Loft, and go from the root foil, hopefully, to the tip foil. Okay, it didn't show up because those closing points are on the wrong sides. I'll click and drag. Okay, that looks pretty good. Has an odd placement of that connecting point. How interesting. Let's actually put these to the front. See if that corrects that. Yes, it does. It's convenient, massively convenient, to have that inbuilt split in the surface exactly for top and bottom. So the difference I'm talking about is now you see that yellow line that's over underneath the black line going across the exact leading edge. With the other choice of closing points, it wasn't exactly at the leading edge. See, it crept up the top surface a little bit. That means that the bottom surface plus the entire leading edge would be one surfaced section, and the top was something different. Because by placing it at the rear side of the airfoil, you're allowing SolidWorks to make its own choice on where to place that. Or if you set these closing points at the front, the exact leading edge, then now these divisions of surfacing make much more sense, and you're good to go. So we'll say, yeah, that's great. Looks good. And there's a very, very simple wing. It makes no, I should say very little aerodynamic sense for this type of airplane to have such a high camber wing, but hey, we're just using what we've got. It's kind of a fun thing. Let's go to the tail. And the first thing you want to do is set up planes at any sort of significant division you want to have. I guess, will the top plane be suitable? Nah, let's not use that. Let's be a bit more specific. This is a lesson after all, right? So with the geometric reference, make a plane that is offset from the top plane. Let's just put that as not 14 inches. What does 1 inch get us? Something, not much. Let's see if I can adjust it with this arrow. Nope, that'd be too convenient. Actually, 1 inch looks about right because it'll be at the base of the tail right there. So yeah, that's a good enough definition. So we have one plane 1 inch up. Let's make another plane at the top height of the vertical tail. So offsetting it from the previously defined, so that is selected, that's good. Say we wanted a vertical tail that is 5 inches tall. Cool, great, wonderful. Let's go to plane 6, and here you could either bring in half of an NAC asymmetric airfoil, or really These symmetric shapes are so easy to draw that I'm just going to kind of make one up. Now, when dealing with vertical tails, it is possible to be too thin. You need to think about structural height. You need to think about structural stiffness and other matters. So don't make it so skinny that you won't be able to get any sort of meaningful strength. Let's bend this out, get a decent size going there. And really, unless you're going to be building the tails into your molds, which we're going to have a lot more conversation about as you get towards the molding portion of these assignments, you probably don't need to worry too much about making these exact. In fact, in this in this actual DBF competition year, they ended up using flat plate, just built up balsa wood tails because they're the lightest and honestly the quickest to make too. Didn't have to make molds, didn't have to mess with all those other time sinks. So that's a half foil, because remember everything in the airplane is going to be mirrored, so we're going to do the same thing with the vertical tail since it goes right across the parting plane. And then so now here on the plane 7, the top, we're going to do the same type of sketch, but of course making it smaller in chord so you get a nice taper ratio on your vertical tail. So let's see here, going back, do a bit of clicky. Oh, that's annoying. So I think is it Shift or you hold down Shift, Alt, and Control? Yeah, so Shift, Alt, and Control gets rid of all the snapping. You can see it's trying to be nice and help you line things up. That's just at this point being annoying because there's too many things it's trying to snap to. When I'm doing a when I'm doing a free-form drawing, well, that's interesting. It just didn't let me continue. Let's try that once more. So Alt's not it by itself. Shift cancels out the operation, so we don't want to do that. Interesting. It used to be all three of them. Maybe yeah, so now it's just Control by default that eliminates the snap to. Okay. Let's just go to the leading edge, and fewer control points this time because the shape's very, very simple. I do want to have that horizontal, so the leading edge creates a nice stagnation point there at the very front. Turn this around because that would make no sense to have an inverted trailing edge. And honestly, I want to preserve similar structural thickness just so we have a very stiff, stop snapping to everything, a very stiff vertical tail for the entire thing. Okay, so that should be fine, maybe a bit shorter. Just look at it proportionally, see if that makes sense. Yeah, good enough. Same thing again, we'll just go to Surfaces, Loft, and in this case, instead of having an entire, come back. Instead of having an entire surface, you just click that, and we get half. Of course, we need to use these closing points together. We get half of that loft put together. Oh, but that's a problem. Good to know. Let's go ahead and accept it. You can actually go into this loft, into the first sketch. Which one is that? Which sketch is which? That's the one we want. Right, yeah, 11 is before 12. So we'll edit that and pull the trailing edge a bit forward just to make this work out and stay inside the airplane. Oh, it has control points. Delete. Snap to the center line. Reduce that stiffness a bit just to make the shape nice. Does it look decent? That might be okay. So it's all inside the OML now? Yeah, pretty much. And of course, you could take much more extended efforts to really, really make this trailing edge of the fuselage come together and look nice and smooth. You can integrate them into the same shape and everything else. But overall, this should be fine for now. Wow, the vertical tail is far too big. I have to fix that. I can't allow that. Let's shrink the tip cord. Actually, make it shorter. Yeah, I could have actually used dimensions and things like that, but the exercise is left to the reader. Isn't that what you say when doing these type of things? Okay. Maybe? Possibly? Things look nice. Alright. Still too big, but whatever. Let's actually just shrink plane 7 so you can actually right click on plane 7, edit the feature. Instead of being 5 inches tall, let's make it 4. It'll be pretty swept, but hey, that's starting to look more reasonable. It might take about that much to keep this plane stable anyway, especially with high lift airfoil, having lots of moment capability out there at the tip if part of it stalls and the other doesn't. So that'll be fine. It looks kind of neat. And of course, the last piece that we need would be a horizontal tail. I actually think it'd be beneficial to have a simple block and make our lives much easier if we had a simple NACA symmetric foil section. So I'm going to make one real quick. just of my own devices. Well, alright, fine. I'll do it the right way and actually get it in a CA foil. Airfoiltools.com. Alright, here we go. 2006. There we go. Grab it, right click. We save the picture. That's the whole page. Alright, snip. Picture. Okay. Throw it on the desktop. That's all we need from you. So here we'll do new sketch. Tools. Sketch tools. Image. Oh, have to be in a sketch first, right? Now if this seems like I'm going through this too quick, well, that's because there's another video specifically on this part. So if this doesn't feel familiar to you, then go watch that video. Much slower pace, much more educational. I think you'll like that experience much more in learning how to import a airfoil. But for now, I'm just going to do unit length. Obviously, it's way out of scale. Double click the picture to get back into it. Scale it down. Get things of appropriate location. And this will really just make it much more of kind of an official airfoil for your tail. Yeah, maybe. About like that. Okay. Do a little spline. Click there. And the back. Just playing the game of getting this shape to be roughly correct, because keep in mind, as thin as this is, you're going to mess it up more than a little sketch error here whenever you're sanding it. So the nice thing about symmetric airfoils, you have the convenience of just mirroring one spline right across the top. Need to be in the sketch to make a block. Tools, blocks, make, block entities, all of those. Insertion point, dragging it to the leading edge, call it good. Right click on the block, save block, and we can put that on the desktop as well as a 0006. Okay, job done. Minimize that, don't close it, just in case we had a mistake. So now to make the horizontal tail, let's go onto the right hand plane, do a sketch, new sketch, go here to the back, and we can insert, well, I guess it's under tools. I think it'd be insert a block, but okay, whatever. Blocks, insert, browse for the new file. Should be on the desktop, 0006. 1 inch long. In fact, instead of that, let's have the root of the airfoil be 7 inches, 0 degrees. Actually, some negative incidence is typical for horizontal tails. So let's do like -3. Looks right, flies right, right? Let's go through about there. Actually, you could have it hanging out structurally. Let's do that. That sounds fun. That keeps, the control surface out very far in the back. We'll only need one copy. Let's go ahead and escape out of that. And then we can make another plane to place our last sketch on, and that would be offset from the right plane here. Yeah, sure, 4 inches sounds about right. Let's go one more. Doing a sketch on that, and bring in, for the last block, 0006. I don't even remember what the root chord was anymore. But anyway, 3 inches seems about right. We'll line up the trailing edges, so that way the elevator will be unswept. No reason for a dehedral. Keep it simple. Same incidence, so we can build the thing flat. And okay. Sketches are placed, leaving only surface, loft, this cross section to this. What? Come on. Apparently it's not selecting the whole path. Oh. I think I might see the problem. Good thing I didn't close that other thing. Let's go back and edit the block. Because I didn't turn that horizontal line into a sketched line. Let's save. Interesting. Guess we need to edit the block. Now this will be an interesting question. Will it automatically update over here? No, that's unfortunate. See if we can edit this block real quick. Should be easy. Change it one place, it'll change in the other. To turn that to construction geometry. Exit the block, exit the sketch. Now we should be able to loft it much more nicely. We had 3 real lines instead of just 2. Align these starting points. What? No. Okay. Here we go. Trying to go a little bit too quick. I need to slow down, as would be the advice. Okay, I also need to reevaluate my horizontal tail volume because that's hilariously too big. Easily done. Just go back into the sketch for the root, click on your block, change its size there. I don't know, 5? It's swept, but that'll make it look cool for now. Hard to build. I would not recommend doing that on an actual airplane. Like, keep your horizontal elevator with a straight hinge line. But anyway, that's now going to be kind of half the airplane. You can obviously see how these elements can be moved forward, backwards, swept, give it dihedral. Basically just defining airfoil cross sections at different points and doing a loft between them to make nice linearly interpolated airfoil sections, or wing sections I should say. Easy enough, and of course the last thing you'd want to do here, if we're going to create an actual sealed outer mold line, which I guess my nose disappeared, but that's okay, we can do that later. I would actually go to View, Hide Show. Let's turn off planes because we have a bunch of them now. That makes it a bunch more clear. Let's go to Features, Mirror. Mirror face planes, do it on the right. Features to mirror. Let's do bodies to mirror. Yeah, maybe. I just had another thought from the future, really. It's a future thing that's going to come back to get us if I don't do it now. Let's show you why. Let's do it the wrong way first, and then I'll go back and fix it. So right plane, let's go ahead and mirror all of these bodies across. This one, this one, this one, this one, and the tail piece. I think that's everything we've got. Should make something that looks more or less like a plane. We do the same thing from a previous video under surfaces and do a filled surface on these 2 chunks. Okay. Wow, that took a while. So if contact, let's do tangent. Got it. Alright, good enough. Just accept that for now. So that is pretty close to being a closed element. Obviously, see the top of the vertical tail, tip of the horizontal, tip of the wings are open, and there's a specific type of surface called planar surface that only forms flat items. When you want to make sure that the thing you're closing is flat, it's the way to go. So planar surface here. And actually, see if I can put that in before the mirror. Yes, nice, because now it'll actually do it on both. Well, if I select it in the mirror, it will do it on both sides. And let's go insert the other one before the mirror as well for the horizontal tail. So that way we can include it in the mirror as well, and instead of having like 3 different mirror operations to achieve what's really just one idea, you can use one mirror operation, select all these elements that now exist before its creation in the tree. And fewer clicks, faster progress. That's what it's all about, right? So now this looks like it has the potential to be a watertight model, and it kind of does. I mean, it more or less is about there. Let's go ahead and move along that process a bit. You're going to try to go in here and say knit surface. Let's do the wing, fuselage, all these different pieces that we've made in order to make a very closed, very watertight element. Horizontal, vertical, little tip sections, so the tail cone, that bit, these bits, all of that. Oop, and that giant piece glaring me in the face. So you would say, all right, it looks sealed, it looks closed, but it won't even join. You can't even knit it together. And the reason you can't is if you really look in a transparent sense, you still have the wing going through the center of the fuselage, you have the vertical tail going in, then ending in empty space, you have the horizontal tail chunking through it. These are what are called non-manifold surfaces. They don't have just a single surface. It doesn't have a nice way to intersect things. So what we can do at first is think a bit more strategically where we'll knit together the fuselage, because really that creates one sealed component that we want to attach things to. So let's go ahead and knit that into one piece, making sure I've only selected what I want. Man, far too many visible things. There's a surface knit. I'm trying to figure out why it doesn't highlight the whole thing. It should select and highlight the whole body whenever I click it. Hopefully that doesn't mean anything bad, because those are still visible, which is okay. Well, we'll see. The next path that you need to be not concerned with, but you need to take is now the idea of trimming. Trimming these surfaces to match one another. And it's pretty simple. It's kind of a Boolean operation for surfaces. One of the devices becomes the tool for cutting, and then the other becomes the object that is actually cut. So the trim tool on a standard trim, which we'll get into the difference between standard and mutual as well. The tool then becomes the device that is doing the cutting, and we want to keep the wing, keep that section, that. Hopefully we can do this all in one. That'd be nice. I think that's all we need to do. Say okay. And if we've done this correctly, which it looks positive at first because we have a blue line appearing right there at the boundary, we should be able to go to hidden views and see nothing going through the middle of the plane. But what's interesting is that there's still one problem. If we hide temporarily this wing, which has been trimmed, so it cut off that central part, if we hide it, you notice the fuselage is still solid. Well, not solid, that's misleading. Fuselage has not had an appropriately shaped hole cut out so that it can become a manifold surface with the wings and tails and everything else. So instead of doing a standard trim, what I want to do to make this easiest is go and use the other kind of trim, which is called a mutual trim, where both basically select all the surfaces you want to do trimming, and you can keep the selections. Now, that's interesting. Oh, maybe that was it. Okay, it's much happier now. It had to have that full surface. So now you just click everything you want to keep. What? That seems backwards. Well, I'll keep clicking in the way that I've used it before, and hopefully this isn't just a bug or a change in. So those should be the elements that it's removing. We've selected the things I want to keep. Let's spin the behavior previously. Let's see. Oh, actually, yeah, that's they've changed how those are selected. That's really odd. But so now if you try to hide, not only did it cut them, but it looks like it already merged them. If we hide this, it actually hides the entire body, leaving only just the tips out here, those little flat surfaces we added back in. So let's show those once more. And then lastly, now you can actually include these little closeouts so that we obtain a watertight model. Which these closeouts are the simplest kind. You could do something fancier if you really cared to. So that looks nice because we now have the option to create a solid, which really means that it's watertight. SolidWorks doesn't really show up let that option show unless you have a very nicely conditioned surface. But overall, that is now one surfaced body that represents the entire aircraft. The nice thing about this is you can go all the way back in wherever you want. Like, where did I define the wing? Nope, that's the horizontal tail, vertical tail. This block defines the wing. And if I cared to, you can edit this sketch, click on that sketch block, and change the root chord to 8 inches. Accept that sketch change, exit out, and SolidWorks recalculates the entire airplane, showing you the new layout, the new blend. These changes are very easy to implement, and it's one of the very beautiful things about doing some sort of mock-up and conceptual design in SolidWorks. So it'll be fairly robust. You don't even really have to worry about proper intersections and proper trimming if you're just doing it for conceptual pictures. But it's just really great and fast to modify designs. Once we start adding blends between the wing and the fuselage, the ease and simplicity of that goes away a lot. So enjoy this simplicity while it exists, and don't go into blending everything until you're ready to commit to a particular OML shape.